All right, for today, we'll finish up the rest of the pharmacy math review. All right, allegation. So allegation is when you have two supply strengths and one order strength, and there's two types. So for the first type, type 1, you're given the final amount. That's very important. So the final amount in the order is the 1,000 ml. So that's how you know it's a type 1 allegation. So you have 5% dextrose and 70% dextrose. Right? So here's the 5%, here's the 70%, and somehow you got to pour enough of each in order to make 1,000 mLs of 25%. Right? So these are your two supplies, 5 and 70. How much of each do you need to mix together in order to get the exact order? So to do the math, we set up a tic-tac-toe grid. So sometimes allegations called tic-tac-toe. So your first step is to put the ordered concentration in the middle. So the ordered concentration is 25. So you don't need the percent sign. And then you have two supplies, 5% and 70. You're going to put those along the left-hand side. So here's 70, here's 5. Next step, you're going to find the difference. What's the difference between 70 and 25? 45. So no negative numbers, just the difference. The difference between 5 and 25, 20. All right. So these numbers represent parts. Right? So you don't have to know exactly what these numbers mean. You just have to follow the steps. So the order in the middle, your supplies on the left-hand side, and then find the difference diagonally. So we have 20 and 45. We're going to add those together. Right. What happens when we add those together? 65. So we got 20 out of 65, and we got 45 out of 65. And the last step for us is to multiply by the final volume. So that's how you know it's type 1. The last step, you're just going to multiply by that final volume. So just round to the nearest ml. What'd you get for the top one? $308. Okay, 308 mLs. All right, go ahead and punch in the bottom one. 45 divided by 65 times 1,000. Okay, yeah, so that should be correct. So you got two concentrations, two volumes. It's very easy to flip-flop and invert the concentrations. So the 307, or sorry, the 308 mLs, that is 70%. Right? So you take this number here and you follow it all the way over. And then down here, that's 692 mLs of the 5%. So here in the picture, we're going to add in 692 mLs of the 5%, and we're going to add in 308 mLs of the 70%. So when we add those two volumes together, we have 1,000 mLs, and it should come out to 25% overall. So just follow the steps, and we'll do another example of type 1 allegation. Oh yeah, the question might be, hey, how much of this to use? How much of this to use? So if you give them the wrong number, it'd be incorrect. Okay. Right? So the first step, what's the first step, guys? You put the order in the middle. So here our order is 20. Next step, put the supplies on the left-hand side. So we got 50%, and sterile water is just 0. The next step, we're gonna find the difference. So what's the difference between 50 and 20? 30. What's the difference between 0 and 20? 20. All right, we got 20 parts, 30 parts. How many parts altogether? 50. So we got 20 out of 50. And we got 30 out of 50. And in a type 1 allegation, what is our final step? Exactly. Multiply by the final amount. In this case, 200 mLs. All right, what'd you get for the top one? Yep, 80 mLs. And the bottom one's going to be 120 mLs. All right. So, what is your total volume? 200 mLs. All right. How much SWFI did you use? Are you sure? How much did you use? How many mLs did you use? 120. Very good. So, yes, SWFI is 0%, but the volume you use is SWFI. So if you said 80, you did all the math correctly, you just entered in the wrong number. So how much 50% did you use? Yeah, this percentage goes with this guy. So be careful when you're answering the questions. Put in the number they're asking for, the volume they're asking for. All right, last one for type 1 before we get into type 2 allegation. So here the order is 3%. We have 23.4%. And what is NS? 0.9. So order in the middle, supplies to the left-hand side. Let's find the difference here. Looks like 20.4. And then the difference here is 2.1. All right, so let's add them together. 2.1 and 20.4 gives us a total of 22.5. And the final step, multiply by the final amount. In this case, 500 mLs. All right, go ahead and punch those numbers in. Let me see what you got. So what'd you get for the top number?
467.
467?
467.
467, and then the other one?
I got 47. Oh, that's.
This one's 40.
I got it from the top one.
Yeah. Oh, this one's 46.7. Okay, so that one's 47. And then this one was 453. Yeah. All right. So, how much normal saline did you use? How many mLs did you use?
153.
Yeah. So, if they're asked for normal saline, it would be that amount, NS. All right, let's go on to type 2. All right, in type 2, you're given a starting amount. So in type 1, you're given an ending amount. Here they're telling us, you know what, use up all of this 25%. And there's only 50 mLs of it. So what we got here is 50 mLs of 25%. And they're telling us, hey, pour in some 5%. But we don't know how much. And then in the end, it needs to be 10%, right? So once you're done, in the end, you need 10%. But you don't know the volume because you don't know how many mLs you entered, right? So that's what we got to figure out. How many mLs of 5% to add? So how many mLs of 25% are we going to use? 50, right? So this is given. So half of the job is done for you. So if they ask how much 25% to use, you say 50. Right? So you just have to find the 5%. And then if you add them together, 5% volume, 25% volume, you would get the 10% volume, right? Because whatever mLs you added, you just add it to this guy, and then you get the volume. All right, so start it the same. You put the order in the middle. You put your two supplies on the left-hand side. We got 25 and 5. We find the difference. Here's 15. Find the difference here. It is 5. So this is where all the similarities will end, and this is where you also want to stop. Right? So this is 25%, and that's going to equal to 50 mLs. So as you recall, this is the 25%, and that means this 5 must equal 50 mLs. All you have to do is solve for 15. So if 5 equals 50, what would 15 equal? 0, huh? For $5, you get 50 mLs. For $15, how many mLs would you get?
Oh, I thought you were trying to get those together.
Remember, it stopped. You end right there. So what's given, you have to match it up with the percentage. So 25% here, 50 mLs there. So 5 equals 50 mLs. What would 50 be? 150, right? So if you're in doubt, just do 15 over 1. Your conversion factor is for every 5, you get 50 mLs. There you go. So 15 times 50 divided by 5 is 150. And it's just a proportion. If 5 parts equals 50 mLs, what would 15 parts be? Right? You guys can solve proportions, right? You guys know how to solve proportions. $5 get you 50 mLs. What would $15 get you? 150 mLs. So if I ask you how much 5% did you use, you're going to say 150 mLs, so 5%. If I ask you how much 25% did you use, you're going to say 50 mLs. And if I ask you how much 10% did you make, you're going to say, well, we started with 50 and I added 150, so my total needs to be 200. So those are the 3 volumes I can ask for. How much 5%, how much 25, and how much 10%. Make sure you answer the correct answer, the correct question. Put the correct answer in the right spot. All right, let's do another example, a type 2. So, order in the middle. Supply on the left-hand side. Then you're going to find the difference diagonally across. And now you're going to match up this volume. So, I got 15 parts and I got 55 parts. Where does the 100 ml go to? Where does the 100 ml go to? So 15 parts equals 100 mLs. What would 55 parts equal? Solve for 55 parts. So this is an equality. You can use it as a conversion factor, as we learned in Math 2. So anytime you have an equality, use it as a factor of 1. So you need to solve for 55 parts. Just put it over 1. Your conversion factor is 100 mLs is the same as 15 parts. That way your parts cancel out. You do 55 times 100 divided by 15. And that'll give you your answer. So I got about 367. What you guys got? $55 times 100 divided by 15. Yeah, 367. All right, one last example. So there were previous videos. Make sure you guys view that before class and upon working on the DCs. They're exactly similar to these. I go over them the exact same way.
So it's 366 for this one?
Yeah, about 367 ml. So that is how much water you use, because the amount of 70% is given. The amount of 15%, just got to add them together. 100 plus 367 for 467. All right, one last example. Let's see what you guys retain. All right, what goes in the middle? 60. All right, what do you want on the left side? 85 and... All right, next step. So the difference here is 25. The difference here is 45. All right. So I got 45 parts, 25 parts. Where does the 75 mLs go to? The 25 parts or the 45 parts?
45.
The 15 is there, so this must equal 75 mLs. So all you have to do is solve for 45 parts. How many mLs is 45 parts? Set it up. This is your conversion factor. You guys know how to convert. Week 2. So, how many mLs of 85% do you need?
45.
So you're solving for 45 parts, and your conversion factor is, for every 25 parts, there are 75 mLs. So the parts go on the bottom, 75 mLs go on top. So if you're having trouble converting, go back to Math 2, review the videos. There's a couple of them. So the parts cancel out. 45 times 75 divided by 25. So I got about 130 something. All right, so that's how much 85% will use. So take a look at the DC, go back, give those another shot, and we'll get into online B after the presentation. Right, flow rate and drip rate. So the units of flow rate is easy. It's just mLs per hour. And all you have to do is simplify per hour. So for example, number 1, just put the mLs. So it's 100 mLs over 1 hour. Easy enough. That's it. You're done, because it's already 1 hour. So you'll get 100 mLs per hour. Super easy. All right, number 2. 250 mLs over 3 hours. Punch that in. All right, so you'll get 83 mLs per hour. All right, now do number 3. What is the flow rate for number 3? Yep, 125 mLs per hour. So just be mindful of your units, mLs and hour, and it's pretty easy, not too bad. Let's do a couple more. Let's do 500 divided by 6. What do you get? 83 mLs per hour. How about 2 liters ATC?
2,000.
How many hours around the clock?
24.
24 hours. What? What? The same?
You said 2,000 divided by 24.
Yeah, it's the same.
Yeah.
Let's do one more. 50 over 30 minutes.
83.
No. Almost better. So, how many hours is 30 minutes?
25.
Yeah, half an hour. So we can just convert that into hours. So this would come out to 100 mLs per hour. But we're not going to give them 100. We're just going to give them 50, but we're just going to pump it into them really, really fast. All right, so the pharmacy will put flow rate on the labels of IVs. However, when the nurse administered the IVs, they're going to use drip rates because they can't wait around an hour to see if the flow is correct, but they can wait around about a minute. So drip rate will be in drops per minute. All right, so for the tubing set, so you have your IV bag, and then you have your drip chamber. Right? So it's usually half filled, and then you have drops that fall into it, and then this goes into the patient's arms, right? So that drip chamber, the drops, the size of the drop will determine on how thick the tubing is, right? So if you have really thick tubing, big drops. If you have really tiny tubing, tiny drops. So the value will be different. So if you ever hear micro drip, it's always going to be 60 drops per ml by definition. So you have to memorize that. They may not even give you 60 drops per ml. They might just say micro drip. You got to know. If it's macro drip, bigger drops, then they have to tell you. They'll give it to you. 8, 10, 15 drops per ml, etc. So we're going to convert from flow rate to drip rate. So it's always easier if you just start with the flow rate. And then it'll take 2 easy steps to go to the drip rate. So for example, 250 mLs over 4 hours using a 10 drop per ml tubing set. So we'll start with the flow rate, 250 mLs over 4 hours. The first step is to divide by 60 minutes. So that's step number 1. And the second step is to multiply by the drip factor, in this case 10 drops. And that's it. Now you are in drops per minute. So go ahead and punch that in. 250 divided by 4 divided by 60 times 10. How many drops do you get per minute? $10, $11? What'd you get? 10? 10 point something?
10.416.
Okay, so about 10 drops. So what the nurse will do is they'll adjust the tubing and they'll wait and they'll count over a minute for about 10 drops, and then they will know the flow rate is set correctly. Right? So they can't wait an hour, but they can wait about a minute. All right, 500 mLs over 6 hours. So we'll start off with the flow rate. 500 mLs over 6 hours. First step is to divide by 60 minutes. And the second step is to multiply by the drip factor. In this case, it is 15 drops per ml. So how many drops per minute?
Do we round up or round down?
You can round up. So about 21, 22, 21 drops per minute. Number 2, we got mLs per minutes, so I'm okay with that because they already did step 1 for us, right? So this is normally step 1, this is step 2. But since we're already in minutes, all we have to do now is step 2, which is multiply by the drop factor. So 100 divided by 30 times 8. You got 27? 27 drops per minute. All right, this last one. I got 50 mLs over 2 hours. First step, divide by 60 minutes. Next step, multiply by how much? How much is micro drip?
That's
60, yep. So they didn't tell you, you just have to know 60 drops per ml. Yep, 25 drops per minute is your flow rate, drip rate. All right, last few things on the math is pediatric dosing. So for Tuesday, Wednesday, Thursday, it's all pediatric dosing. So let me rewrite this formula to make it easier. So Fry's rule is for infants, less than 1. So it's months over 150 times the normal adult dose. So AD stands for the adult dose. So if you write it this way, it usually makes it easier. So for example, this patient is 6 months. Just put it over 150, and then the regular adult dose is 250 milligrams. Weight's gonna, for infants or for children?
Let's say they put 80 pounds over. What's one of the daily checks you're supposed to do?
Okay, so that's a different rule. That's gonna be Clark's rule. So Fry's rule is for infants, anybody under 1 year of age. So hence age in months. So if they're over 1 year and you want to do it by weight, you're going to use Clark's rule. So that's a good question. You have to identify which one to use. So in this case, based on the age less than 1, you're going to use Fry's rule. So how much drug would you give this infant? So punch it in. 6 divided by 150 times 250. Milligrams. So the adult dose is 250. Look how much less you're going to give an infant. Smaller bodies, underdeveloped organs. All right, 9 months over 150. In this case, the adult dose is 1 gram, which is 1,000 milligrams. So adult would get 1,000 milligrams. How much would this child get? $40? You got 40? Yeah, that's about right. That is way less. So you can see how difficult it is sometimes. She's confirming. Is that right?
Yep.
60.
60 now?
Yeah.
60. All right, let's change this kid's birth date. All right, so you know how old this presentation is from last year. All right, how old is the kid if they were born 8/12/2017? How many months is that? So how many months is that? We got till September, October, November, December, January, February, March, April, May. Yeah, about 10 months. So they're about 10 months over 150, and the adult dose is 40. So this child will get how much? 2 point something? So a little itty bitty amount for this child. So that was Fry's rule for children, infants under 1 year of age. Now for Clark's rule, it's going to be for children 1 to 12, and it's very similar. Instead of age in months, you're just going to do body weight in pounds over 150 times the adult dose. So for this first example, we got 65 lbs over 150, and the adult dose is 500. How much would you give this child? All right, I'll have you guys do this one. Anyone give this one a try? Very good. So first you have to convert to pounds. Very good. What'd you get? 92, yep, about 92. All right, let's do it one more time. 48 kilos? About how many pounds?
106.
Okay, 106 lbs. So,
Rounded up,
yeah, that's fine. 106 is fine. That's fine. 106 pounds over 150 times 500 micrograms. All right. Yeah, we'll keep it as micrograms.
Okay.
So 106 divided by 150 times 500. 332 mics, MCGs.
Oh, so 352.
352? 352. We'll change that till 5. All right, not too bad for Clark's rule. So Clark's and Fry's rule is very similar. One is months under 1 year, and the other is pounds for children. All right, the last one is Clark's rule. So you're going to take their age in years divided by the age in years plus 12 times the adult dose. So this one is the one that looks kind of funky, a lot different from the other ones. So again, it's going to be for children. So if you're giving weight, use Clark's. If you're given age, then you're going to use Young's rule. And the way I remember is I'm young in age, right? All right, so this kid is 10. And we're going to put that over their age, 10 plus 12. And then we're going to multiply by the adult dose. So let's simplify this a little bit. 10 over 22 times 50. So don't forget to do everything in parentheses before you divide. So 10 divided by 22 times 50.
23.
About 23 milligrams. Based on age. Did we just do this one? Yeah, we just did this one. I need to change it. All right, we'll skip this one.
23 milligrams.
I guess this was just a sample. All right, so that completes all the math. Let's go on to online B, where we can try it out.